You're watching the second lesson in squaring and square roots. In the first lesson, we talked about how to square a number and why it's called a square, and the common mistakes that happen when you square numbers. Now we're going to do something a little bit harder. It's very closely related to squaring numbers, but we're going to go backwards. So we call these square roots, right? We call these square roots, and this is the symbol that we use. It looks very similar to the long division symbol, but it's got a little tail on it. That's how you tell. So what does it mean to square a number? So hopefully you remember that from the last lesson. To square a number means to multiply by itself. So 4 squared, if I square 4, I'm multiplying by itself. So 4 times 4, which is 16. Right? The little number here called the power or the exponent is telling you how many numbers of this one you have, how many times you have this one. Right? The big number here, called the base, is the number you're using. The exponent is the number of times that number shows up. So we have 4, and this little 2 is telling me I have 2 4s. So that's 4 times 4, not 4 times 2. Please never make that mistake. So square roots are the reverse of squaring a number, right? We know 4 squared is 4 times 4, which is 16. Well, then we can say the square root of 16 is 4. And we show this by doing this symbol and showing this, which equals 4, right? So we show this symbol, which is called a radical, put the 16 under there, and then say it's 4. So in this case, we went this way, right? We went 4 squared equals 4 times, whoops, 4, that looks like a plus, let me fix that. 4 times 4, right, is 16. Right? So if we're doing squaring numbers, we're going this way. If we're doing square roots, right, if we're doing square roots, we have 16, right? And we're looking for a number, so let's say x. Let's use x as our number. So this would mean x times, and I'll use a dot to show multiplication, times x, right, gives me x squared. Because remember, that little 2 is telling me how many of that number I have. So we're looking for the number, if multiplied by itself, would give me 16. So we're going backwards. This way, we're going forwards. We're going 4 squared. Oh, I have 2 4s, so that's 4 times 4, and that's 16. In this case, we're saying the square root of 16, well, we're saying we have 16, and we're trying to find the number that multiplies by itself to give us 16. So we're going backwards. Instead of going 4 times 4 is 16, we're going 16, well, something times itself gives me 16. So what is that number? So we call numbers that can be square rooted, right? 16, for example, can be square rooted. A number such as 4 times itself gives me 16. So we can call 16 a perfect square. It is a number that if you square root it, will give you a whole number. What is a whole number? A whole number is a number that does not have a decimal, right? So if I were to square root 16, we would get 4, because we know 4 times 4 is 16. So 1 is 1 centimeter, right? So this one is 1 centimeter, this square is 1 centimeter. Make a square with an area of 9 centimeters, or an area of 9. So this is what we're doing. We're trying to make a square, a bigger square, with an area of 9. Well, I'm going to try and go, all right, 2. So the whole area needs to be 9, right? So I'm going to try this one. Okay, so I can take my squares, line them up like so. Now it's not going to be absolutely perfect because I can't match them up perfectly, but overall it's pretty square shaped. And if I counted up the area, each one square is a centimeter, so this is the area of all the squares inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have an area of 9. And it's a square because the length of this side is 3, and the length of this side is 3, right? So if I were to find the area, if I were to calculate the area, this would be saying 3 squared gives me, well, the area is 9, right? That makes sense. Let's go backwards. The square root of 9, right? We have an area of 9. Well, it's saying, well, what side would it need to be for this to be a square and equal an area of 9? Well, it's 3, right? Each side length must be 3. So the square root of 9 is 3. Let's try a different one. Make a square with an area of 8. Well, we want 8 blocks, right? 4, 1, 2, 3, 4. Okay, well, I'm going to try and make a square out of that. Okay, let's try 4, right? Oh, we've run into a problem already, and hopefully you can see that. Is this shape a square? Is this shape a square? No, because remember, a square needs all its sides to be the same, and this is a side length of 2, and this is a side length of 4, right? So it's not a square, it's a rectangle. So let's see if we can we arrange this in a way? Let's try 3, right? And then we'll put the rest in there. And as you can see already, oh, it's almost a square, but we're missing a part. So it's not a square. So we have an incomplete side and a side of 3, right? So this doesn't work. So could you say we could square root 8? No, because you cannot make a square with an area of 8. I mean, you can, but you'd have to use part of a square or part of something, which would mean a decimal. So the square root of 8 is something we would not do because we cannot get a perfect square out of that. Here, we can get a perfect square, and we can see that right here. We have an area of 9, and this side length is 3, and this side length is 3. So the square root of 9 equals 3. What number times itself gives me 9? And you can look at this one too. What number, so we're looking for the square root of 8. Okay, what number times itself gives you 8? Well, 4 times 2 gives me 8, but those are different numbers. 8 times 1 gives me 8. Those are different numbers. And so you can see that there's no number times itself, or no whole number times itself, that would give me an 8. So we know that 8 is not a perfect square, but 9 is, because the square root of 9 is 3, which is a whole number. So try some of these. Identify if these numbers are perfect squares. And so if you want, you can draw boxes, but that'll be a lot of boxes to draw. Pause the video, and I'll do 2 of them to help you out. All right, so hopefully you pause the video. I'm going to show you how to do this one. So we have 25. All right, so we're trying to find the square root of 25. We're trying to see if it is a perfect square. And the only way for something to be a perfect square is if we can square root it. So the square root of 25. What number times itself gives me 25? Well, this one should be easy, right? Because we know 25, okay, well, how do we multiply into 25? Well, the only numbers we can use is 25 and 1, but those are different numbers, so that doesn't matter. But we can also use 5 times 5. What that means is we have a square with a length of 5 and another length of 5, because again, the sides have to be the same. And the area is 25, which makes 25 a perfect square. Well, let's take a look at 24, right? So we're trying to find the square root of 24. So we're trying to find a square. We're trying to make a square with side lengths that are the same because it's a square, and the area is 24. Well, what numbers multiply into 24? Well, we have 6, right? And 4. Well, those are different numbers, so that doesn't count, right? We have 8, right? And 3. 8 times 3, right? Well, that's not going to work. Those are different numbers. And we have 12 times 2. And we also have 24 and 1. I always forget that because it's kind of basic. But again, all of these numbers that multiply into 24 use different numbers. This one uses 5 and 5. So we can say, because they're the same number multiplied by itself, which is 5 squared, you could say 25 is a perfect square. Here, the numbers are different. The numbers are different. The numbers are different. The numbers are different. So 24 is not a perfect square because I cannot make a square with an area of 24. So it's not a perfect square. So try this one and this one. So it's easy to find perfect squares in small numbers. But how do we find out if a number is a perfect square by hand? Well, we use something called factorization. Factorization. It's when you break down a number by its factors. Oh, well, here's a word you probably haven't heard in a while. A factor. What's a factor? Well, a factor is a number when multiplied by another number will give you a third number. So let's go back here. 24. A factor of 24 is 6 and 4. These are factors, right? Because if you multiply them together, they give you 24. So a factor is the parts of a multiplication problem or an equation that give you the answer. So a factor is any number that can multiply into the number you're looking at. So an example would be a factor of 18 is 6, right? Because we can multiply 6 by a number, in this case 3, to get 18, which means 3 is also a factor, right? Because another factor is 9 because 9 times 2. So we know the factors of 18, or numbers that can multiply into 18, are 1 because 1 times 18, so 18 is a factor. 2 because 2 times 9, so 2 and 9 are factors. And 3 and 6 because 3 and 6 multiply into 18. These are all the numbers that can multiply into 18. And so these are all the factors of 18, right? If I pick 12, let's do 12. What numbers multiply into 12? Well, we know 1 does, right? We know, and then 12 on the other side, right? So 1 and 12 are factors because 12 times 1 is 12. Okay. Well, we also know 2 is, right? Because 2 times 6 would give me 12. So 1, 2, 6, and 12 are also factors, right? We also know 3 is a factor of 12 because 3 times 4 gives me 12, sorry. So 1 is a factor of 12, 12 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, and 6 is a factor of 12. These are all numbers that when multiplied correctly can give you 12. So these are factors of 12, and these are factors of 18. These are numbers, when multiplied correctly, can give you 18. So how does this help us find perfect squares? Well, after you found the smallest factors, if there's an even number of each factor, then you have a perfect square. So for example, is 36 a perfect square? Right? Well, some of us can say yes, just by looking at it and going, okay, well, 6 times 6 is perfect square. But sometimes we can't do that, right? Sometimes we can't look at a number and go, oh, that's easy, that's 6. 6 is the square root of 36 because 36 is a perfect square, and if I were to make a square with an area of 36, the side length would need to be 6 and 6. So then the square root of 36 is 6, right? So sometimes we can't do that easily because the numbers are much too large. So we break 36 into its smallest factors. So this is what I like to do. I like to do something called a factorization tree. It basically looks like a tree. And so we look at this and we go, okay, what two numbers multiplies into 36? Well, we can say 12 and 3, right? We know 12 and 3 multiply into 36. So 12 times 3 is 36. Can we find more factors? Okay, well, can we break this down into factors? Well, we'll exclude 3 and 1 because 3 times 1 Well, we could keep going on like this forever, so we won't use times 1. So can we use something other than 12 times 1? Well, yeah. We can factor 12 as well, right? So we have 36, 12 and 3, 12 times 3 gives me 36. And I can break 12 down into 6 and 2, right? So 6 times 2 is 12 times 3 is 36. Perfect. Well, we can keep going, right? We can find the factors of 6. Well, 6 broken down is 3 and 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 3 is 36. So now we found all the factors of 36. Now, naturally, there is 1 and 36, which are factors, 1 and 36. But we don't do this one because it would go on forever. So just know that the number 1 and the number itself are also factors. So once you've done that, once you've gone as small as you can, you go, okay, well, how many factors are there? Right? Right? Once you've gone as small as you can, you have all of your factors. So we have 3 times 2 times 2 times 3. Right? I like to organize them together, 3 times 3 times 2 times 2, right? To get 36. So we know that these factors work. Well, how many do you have? Well, we have 2 2's, and we have 2 2's, and 2 3's, right? We have 2 2's and 2 3's. So if you have an even number of factors of each type of factor, then you have a perfect square. So we have 2 2's, and we have 2 2's and 2 3's. So that means 36 is a perfect square. Now, this may seem like a lot of work, but if this number was 136 or if this number was 1036, it would be much harder to quickly look at this and go, well, what's the square root? So this is a way to solve for perfect squares with large numbers. Right? We can also find the square root this way. So first, we need to pair each factor off with the other, right? We have an even number, so we take a 3, and we'll take a 2. 3 times 2, there you go. And we'll take this 3 and pair it off with this 2. So this 3 and 2 are together, right here. And this 3 and 2 are together, like so. So 3 times 2, 6. 3 times 2, 6. Oh, they're the same number? Done. We know that the square root is 6. So factorizing can give us the whether or not the number is a perfect square, and can also give us the square root. So let's go up and try one of these. All right, let's take a look at 42. Let's see. So hopefully, if you pause the video, you know that 42 is not a perfect square. So let's try this. We have 42, right? Well, what numbers can multiply into 42? Let's try 6 and 7. Perfect. All right. Can I break down 6 and 7 into different factors? Well, 7 is a prime number, so 7 and 1 I'm not going to do, otherwise I'd go on forever. But I can do 6, 2, and 3. Right? 42, 6, 7, 2, and 3. Right? Can I break 2 down more? Not really. 3 down more? No. So these are the factors of 42. So we have 2, we have 3, and we have 7. Do we have an even number of each factor? We have 1, 2, 1, 3, and 1, 7. No. Right? Can we pair off the numbers? No, because they're an uneven number. So we know it's not a perfect square. So factorizing, and you can factorize it in a different way if you want to, and you end up with the same situation. So 42, we could divide it by 2, right? So we can go 2, right? And right now be 21, right? And we can break this down into 7 and 3. And again, we still have 3, 7, and 2. And so again, we still have an odd number of factors, and we can't pair them off. So we know that this is not a perfect square. So we go back down here, Once you've gone as small as you can, and you have all your factors, if you have an even number of each factor, so in this case in 36, we have 2 3s and 2 2s, we have an even number of factors, we can say that it is a perfect square. And if we know it's a perfect square, then what we do is we take one number and we take the other number and pair them off, 3 and 2. And we take this number and this number, 3 and 2, and we pair them off. And we have now a way to find our square root. The number multiplied by itself, that will give us 36. So try these questions on your own. Definitely 15, because I will definitely make a quiz on factorization. And hopefully we can get used to this, because this is a bit difficult. It's a bit long and drawn out, but it's good for finding out if a large number is a square root. Right? It's good for finding out if a large number is square root. So we can do another example if we need to. We could have 100, right? Well, what numbers can we use? Okay, well, let's try divided by 2. I like to divide by 2. So we have 2. Well, what times 2 gives me 150? Well, I can't make 2 any smaller, so I'll see 50. Let's try dividing that by 2 again. All right, and that's 25. And what can I divide 25 by? Well, 5 and 5. Perfect. Right? So we see 100, 50 times 2, yeah. 50 divided by 2 and 25 and 5 and 5. Perfect. All right, so how many factors do we have? Well, we have 1, 2, 3, 4. We have 4 factors. So we know that we have a perfect square, right? And so we have 2 times 2 times 5 times 5. I have 2 2s and 2 5s. So I have an even number of each factor. I have an even number of each factor, meaning that it is a perfect square. Okay, well, how do I find the square root of this number? Well, then I'll take one number, the 2 here, and I'll take the opposite number, times 5. And that'll give us, sorry, my pen's not working, 10. That'll give us 10. And so we know that 10 times 10 would give us an area of 100, or we can say 10 squared is 100. Right? And again, this can go to even higher numbers. It can go to 1,000. It can go to 10,000. It can go to 332. And you can try and solve these questions just by finding it by dividing by 2 or 3 by small numbers and getting all those small factors. And if you end up with an even number of each factor, an even number, so here we have 2 2s and 2 5s. Those are even numbers, right? We have 2 2s and 2 5s. So then we know that it's a perfect square. And then we can take one number from one set and the other number from the other set and get our square root. Hopefully this makes sense. This is a bit challenging and to wrap your head around. There's quite a few steps. If you need any help, please find me in class and I'll be happy to help. See you next lesson.